Let's go to in triangle AGH and triangle DEF. In the two triangles, I can firstly say AG. AG is equals to DE. Why do I say AG is equals to DE? It's because that is according to our construction. Remember, in our construction, we said we should construct mark of AG to be equals to DE. It's not the given information. It's due to our construction. Then the reason should be it's because of the construction. Because of the construction. AG is equals to DE because of the construction. Yes, you can give me the other one. Correctly so, AH is also equals to AH is also equals to DF. Construction again. The reason is still construction. Because that is according to our construction there. We constructed AG to be equals to DE and AH to be equals to DF. That is according to our construction. For us to prove congruency, remember we must have three statements. Check in triangle AGH, we've got angle A, which is equals to angle D. This one, remember, this is the given information. It's not construction. Because the theorem, if two triangles are equiangular, then the sides must be proportional. It means the two triangles were equiangular. Triangle ABC and triangle DEF, they had their corresponding angles equal. Angle A is equals to angle D, B is equals to E, and C is equals to F. Hence, we have marked them similarly on the diagrams. We have marked them on the same way on the diagrams to show that they are equal. So, AG is equals to DE due to construction, AH, DF construction, then angle A is equals to angle D. Based on the three statements, then it means you can conclude that triangle AGH is congruent to triangle DEF. Why do we say they are congruent? Still remember the conditions or the four cases of congruency. Side, pair of sides, the included angle, and another pair of sides. So the reason here will then be side, angle, side. The reason why we say the two triangles are congruent. And you still remember what we mean by congruency. Congruence means equal in all respect. It means triangle AGH and triangle DEF, they are equal in all respect. If the two triangles AGH and DEF are equal in all respect, it means their corresponding sides are equal, their corresponding angles are also equal. They are congruent. By congruency, we mean equal in all respect. Therefore, from congruency, we can then say angle G1 is equals to angle E. This G1 will then be equals to angle E. Remember the two triangles, triangle AGH and triangle DEF. We have proven that they are congruent. So if they are congruent, this angle A is equals to angle D, G1 is equals to E, side AG is equals to DE, side AH is equals to DF, side GH is equals to E. They are equal in all respect. So if they are equal in all respect, it therefore means angle E is equals to G1. Because it's from congruency, because we have proved that the two triangles are congruent. You still remember that? Yes, I can see some of you still remember from the given information. But you still remember that angle what? Angle B is equals to angle E. You still remember? BE. That was the given. This one is from the given information. Because the first statement said two triangles are equiangular. Two triangles are equiangular. By equiangular, it means corresponding all the angles are equal. So it means angle A is equals to angle D, angle B is equals to angle E, and C is equals to angle F. So B is equals to E from the given. That is what was given. Two triangles were equiangular. But G1 is equals to E. This one, G1 is equals to E from congruency. From the two statements, we can draw another conclusion. Therefore, what can you conclude? G1 is equals to E. Angle B is equals to E. From the two statements, what can you conclude? Correctly so. Angle G1 is equals to angle B. Therefore, it means angle G1 is equals to angle B. Look at the position of the two triangles. G1, B. G1, B. We said angle G1 is equals to B. Look at them. Angle G1, B. How do they relate? They are corresponding. G1 and angle B. These are the corresponding angles. And remember, corresponding angles will only be equal if they lie between parallel lines. G1, B. Those are the corresponding angles. And for them to be equal, it means that GH must be parallel to BC. Because corresponding angles will be equal if and only if they lie on parallel lines. We can have corresponding angles, but it does not mean that they are equal unless they lie on parallel lines. So in this case, we've got the corresponding angles that are equal. If the corresponding angles are equal, it goes without the word no that GH, the two lines, GH will then be parallel to BC. Why? Because G1 is equals to B. And G1 and B are corresponding angles. And corresponding angles will only be equal if they lie on parallel lines. Thank you. Therefore, we conclude. Therefore, GH is parallel to BC. Therefore, GH parallel to BC. Let me show you the diagram. Therefore, it means we conclude that GH is parallel to BC. Do you still, should I indicate it? Let me indicate it in red so that you can see the conclusion that we have just now arrived at. Right now, we are at this stage. We say GH parallel to BC. GH parallel to BC. Look at that triangle. Look at that. Maybe I should hide this one for a minute. Look at that triangle. The theorem that we just did right now. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Recall the theorem. We just did it earlier on today. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. So in this case, what do we have? We have GH parallel to BC. To still remember the required to prove part, we've got to prove that AB over DE is equal to AC over DE. So if GH is parallel to BC, we conclude that AB over, check, AB over DE. AB, we conclude AB over, check the order, AB over AG. Check the order, AB over AG. AB over AG. Even on that other side, AC over AH. AC over AH. Can you give me the reason for that statement? What I have written now, remember, GH is now parallel to BC. Now I say if the two lines are parallel, AB over AH. AB over AH is equal to AC over AH. The reason, a line parallel to a side of a triangle. We know that a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. From the given information again, let's carry on. Check AB. We've got AB over AG. Instead of AG, AG is equal to DE. From our construction, AG is equal to DE. So I substitute AG by DE. AC over, instead of AH, AC over AH. Instead of AH, AH is equal to DF. Now I substitute AH by DF. And that is the theorem that we wanted to prove, that this corresponding sides of the two triangles are proportional. If two triangles are equiangular, then their corresponding sides are proportional. We have just proven that AB, check, The order is important again. AB over DE is equals to AC over DF. We are taking sides from two different triangles, from triangle ABC and triangle DEF. Remember, those two triangles were equiangular. Now we have proven that if they are equiangular, their sides are also in proportion, the same proportion. That's why we have concluded AB over AG, AB over DE is equals to AC over DF. That is the proportionality theorem, and I think that was the required to prove part. If you remember, check the required to prove that AB over DE is equals to AC over DF. It is very much important to know the proof of this theorem, because part of bookwork is this one. It's examinable. It can be asked to determine or to prove this theorem. I said grade 12, we've got those two main theorems, proportionality theorem and the similarity theorem, and I have proven them. Please make sure that you understand it, and so that you can also be able to prove this on your own. Because remember, I said there are 85% chances that one of the two theorems will be examined, either in the June examination, September examination, or in the final examination. Because in grade 12, these are the two major theorems. Thank you. I think we've done enough for today. But before I can let you go, I want us to do one last exercise. One last exercise, and I believe that exercise will be based on the application of this theorem. One last exercise, and the exercise will be based on the application of this theorem. Thank you.